Hi everyone, I'd like to talk about an example about chi-square test for independence. So let's first look at the question. A randomized controlled trial was designed to compare the effectiveness of splinting versus surgery in the treatment of carpal tunnel syndrome. So the results are given in the table below, and the results are based on evaluations made 1 year after the treatment. So I'd like to use alpha equals 0.01 to test the claim that success is independent of the type of treatment. So here we have two variables. One variable is the result of the treatment, which is successful and unsuccessful. The other variable is the type of treatment, which is the splint treatment and the surgery treatment. So I'd like to test to see if these two variables are independent or not. Right? So here are the major 5 steps for the hypothesis. So now let's first set up the hypothesis. So for any chi-square test for independence, you can set up the hypothesis as above. And in our question here, the claim will be under H0. Now to transform that into our question, so our H0 should be the result of the treatment and the type of the treatment are independent. And H1 will be that they are dependent. So now let's find the test statistic. So from our table, we need to find the row total, column total, and the grand total. So the row total for splint treatment is 60 plus 23. And you can also find the row total for surgery treatment in the same way. And then similarly, for the column total, for the successful treatment, you have 60 plus 67, and unsuccessful treatment, you have 23 plus 6. And then the grand total will be just adding up all these 4 observed frequencies. And that's the same as if you add up 83 and 73 or 127 and 29. Alright, so then to find the expected frequency for each of the category here, which is, for example, splint and successful, the observed frequency for that is 60, and then the expected frequency for that category will be its row total 83 multiplied by its column total 127, and then divided by its grand total. Okay, so let's look at the last one. So the expected frequency for surgery and unsuccessful would be 6, and then the corresponding expected frequency will be its row total, which is 73, multiplied by its column total, which is 29, divided by 156. Right? So that's how you find all the expected frequencies. Then plug in all the O's and E's into the formula, then you will get this test statistic. So now I'd like to show you how to do this in your calculator. Alright, so first press second and then the x inverse sign here. Right, and then move to edit. Select number 1. So here this is let's go back to our table here. Right. So here we have a 2 by 2 table because there are 2 variables that we're test 2 variables, each was 2 categories in our table here. Right, so then just input your table, just observe frequencies into this matrix here. So we have 60, 23 on the first row, and 67 and 6 on the second row. Okay, so that's all you need to input. And then go to Stat, Tests, and then the chi-square test here. Select Enter and make sure Observe is referred to matrix A, and we don't need to worry about the expected matrix here. Right? And then go to Calculate, and then here you go. So this is the results of your test statistic, 9.750. And it also gives you the p-value as well. Right? So once we have the test statistic, then the rest, it's simpler. So first of all, the degrees of freedom is the number of row minus 1 multiplied by the number of column minus 1. So in this case, the degrees of freedom will be just 1. And then the p-value, you can get that from your calculator directly with the chi-square test function or use the chi-square CDF functions. And then the critical value, so that you have to find it from table A4. right? So now for the decision. So our p-value is smaller than our alpha, so we reject the null hypothesis. And our critical region will be chi-square greater than 6.635. And our test statistic is 9.750, which is greater than 6.635, which implies it does fall within the critical region. So that will also lead us to reject the null hypothesis. Okay, so then to draw our conclusion, then we say there is sufficient evidence to warrant rejection of the claim that success is independent of the type of treatment. Okay, so that's it.